Good morning, everybody. Welcome to this session, Blockchain Introduction in One Slide. So, I propose that we get started. For this Blockchain Introduction in One Slide, which is made possible through the marvelous technology of multiple transitions in one slide. So we will have multiple transitions in one slide. Technically, we remain in one slide. So this blockchain introduction in one slide is kindly proposed to you by the Blockchain Academy, a blockchain consulting and training company based here in Luxembourg. We are also a proud sponsor of the Luxembourg Blockchain Week, and so are glad to have you on for this warm-up session for those who would like to have a quick reminder on what a blockchain is and how a blockchain functions. So we'll try to have the next 30 minutes first to have the presentation, and then we'll open the floor for a few questions. So I'll try to have also sufficient time to answer some of your questions. So I propose that we get started with, first of all, the question, the fundamental question, what a blockchain is. And the answer is quite simple. In its very essence, a blockchain is nothing else than a transaction database, a transaction journal. And you can understand or imagine a transaction journal as an Excel sheet in which on each line you have a transaction. From somebody to someone else, something is transferred to that transaction, is signed and timestamped, okay? So that is a transaction journal. Now, a transaction journal is very, very foundational for the functioning of an economy, for the functioning of a society, simply because the transaction journals constitute the absolute reference in terms of proof of ownership. Okay. Now, traditionally, these transaction databases, transaction journals, are maintained by what is called trusted third parties. So that could be governments, cities, companies, banks, notaries, you name it. These are trusted third parties that maintain these transaction journals for us and create the consensus on who owns what. Okay, and now kicks in the difference between traditionally maintained transaction journals and a blockchain system with its transaction journal. The big difference is that the blockchain transaction journal is maintained by you and me, or at least by your and mine computer. These computers are linked to each other over the internet in a blockchain network, and they collaborate all together in order to maintain or treat and handle transactions and to maintain the blockchain transaction journal. Okay, so that is the fundamental difference between a traditional transaction journal and a blockchain transaction journal. Namely that it's you and me that maintain that database, that transaction journal, in opposition to traditional setup with trusted third parties. So that was the first question that we had to answer, what a blockchain is. Now, the second question is, how does that blockchain function? So what I propose to do in the next 15 minutes, I hope, is to have an operational overview that would allow us to understand how transactions are created, how they are verified, how they are inserted in a block, and how they become part of a blockchain. Okay. Now, up front, we have to note that we are talking here about the type of blockchain that is public and permissionless. So that is the type, the archetype of blockchains, which is the Bitcoin blockchain. So you don't need permission to become part of the entire blockchain system. Let's also note what actually is the very center, the very core of that public permissionless blockchain, and that is the consensus rule. We'll explain a little bit more in detail a little bit later in the presentation, but let's have a first confrontation with this consensus rule. And that consensus rule tells us that the only true blockchain is the longest chain created through proof of work. Okay, so keep in mind, the only true blockchain is the longest chain that is created through proof of work. Okay. Let's set up, first of all, let's have a quick look at the legend here. So in the operational overview, we will have different colors of flows, with the blue arrows indicating the flows of transactions and blocks. The purple arrows will indicate the flows of information, and the green arrows will indicate economic and monetary flows. Okay. So let's set the stage. So recall the blue circle from the previous scheme, in which we had all these participants connected to each other over the internet. Now, each participant on the internet can download one or more of three softwares. You have the software that allows for users to participate in the blockchain system. Now, that software is also called wallets. Then you have a software that allows for any participant to download it on his computer and become a verifier in the blockchain network. Now, when you download that software, then you actually become a node, a verification node in the blockchain network. And then there is a third software which allows you to participate in the system as a block creator, also known as miners. Okay, so these are the guys that do the proof of work. We will see a little bit later what that actually means. Okay. Now, so this is a focus on the three types of roles that you can take on in the system, the three types of softwares. Now, the system doesn't exist in an isolated context. It is directly connected to our economy and our society. So we add here in green our economy, and we'll see how that blockchain system interacts with the real economy, with real society. Okay. And actually, we have a first arrow that goes from our economy, the green arrow, so that's an economic monetary flow, to the block creators. Now, this is the miner's investment. So in order to become a block creator, you don't only need the software that allows you to fulfill that function, but you also need very heavy computers. You need to invest in computing material, and you need to invest in electricity to run those machines. Okay, so that is the first monetary input that goes from the economy to the miners or the block creators. Now, let's have a look at, first of all, the software that allows us to participate as a user, the software called a wallet. Okay, and a wallet has a first function. A wallet allows to create and to safeguard what is called public-private key pairs. Now, these public-private key pairs are kind of our identity in the blockchain system. The public key is, let's say, the equivalent of a bank account number, and the private key is the equivalent of your password to access your bank account, and also potentially to sign and authorize transactions on your bank account. Okay. Now, in order for our identity to be operational, our public key to be operational, we communicate our public keys in the economy. Okay. For example, we could publish our public key on our website in order for people to be able to use that public key and send us a transaction, a Bitcoin transaction, or whatever type of blockchain we are operating in. That could be any kind of ownership. It could be physical ownership of cars, houses, computers, bikes, you name it, or intangible ownership of intellectual property, of art, of also our digital trace we leave on the internet. That also is data and could be our ownership, actually, and so could become attached to our public key. So in order to create transactions, we need to communicate our public keys in the economy, publication or communication through direct messaging, whatever. Okay. The second function of the wallet allows us to create and sign transactions. Now, transactions that are linked to the real economy, so transactions between public addresses. And when a transaction is signed, then that transaction is also broadcasted to the network over here of nodes. The verifiers receive that transaction. Now, it's important to note that a wallet will send the transaction to the nearest node in the network. And then that node will forward that transaction to neighboring nodes, to neighboring verifiers. Okay. And those neighboring nodes, when they receive that new transaction, they will do the same thing. They will forward that transaction to their neighboring nodes. And in that way, new transactions ripple in fractions of seconds all over the network, all over the world. Okay. And then all these verifiers start to verify that transaction. This verification consists of three elements. The first element is the validation of the authenticity of the transaction. The second element is the validation of the integrity of the transaction. And the third element is the validation of absence of double spending, or the validation of accounting coherence, let's say. Okay. Now, the validation for the authenticity is all about determining if the transaction has been signed by the private key that is attached to the public key that appears in the transaction. The integrity of the transaction is all about determining that that transaction hasn't been changed since its signature, since its creation. Okay, and for those two verifications, the blockchain system holds cryptographic tools that allow to validate, to verify and to validate those two elements. The third element, the absence of double spending, or verification for coherence, for accounting coherence, is all about verifying and confronting the transaction with the accounting history that is already present in the transaction journal in the blockchain. Okay, so verifiers will go through the entire history of transactions in order to determine if the new transaction, if there is no conflict with the already existing transactions. And when a transaction is accepted, then it is placed in what is called a mempool. It is a waiting chamber where verified transactions are waiting to be picked up by the miners. Okay, and that allows us the transition to the activity of a miner. Now, what is very important to understand is that these miners, they are here for business reasons. They made an investment and they want to make a return on investment. And how do they do that? By creating a block and by receiving a reward for creating that block. Okay. Now, it's here that intervenes again the consensus rule. The longest chain produced by proof of work is the only true blockchain. So that means that only one block creator, one miner, will be able to propose a new block to be added to the blockchain in order to become the new longest blockchain. Okay, so that sets the stage for a race. The miners will race in order to be the fastest, in order to be the first to propose a new block to be added to the blockchain. Now, let's have a look at how these block creators create their block. Now, a first element that they insert in a block is the reward transaction itself. So they can write themselves, to their own public address, the reward transaction. And the reward transaction, for example, in the Bitcoin blockchain, is newly created Bitcoins, newly minted Bitcoins. Out of thin air, you create new Bitcoins. And that is what happens here in the reward transaction. And then the miner will pick transactions from the mempool and insert those transactions in the block that the miner wants to create. Okay, and he can do so until that block is full. In the Bitcoin blockchain, there is a limitation on the size of a block, and that limitation is 1 megabyte. Okay, so you can consider a block here as a kind of a page in a grand journal, and if that page is full, then there is no place anymore to insert supplementary transactions. And then as last element, the block creators, the miners, have to insert a block signature. Now, what is very specific about that block signature is that that block signature is not known upfront. And that block signature can only be found by iterating a field that is called the nonce. The nonce is actually an abbreviation of number used once. Okay, so that is a field in the block that we didn't show here on the page, but it's there. It's called the nonce, and so an iteration process is needed in order to find the number that creates the block signature that is compliant with the protocol rules. Okay, now, and as said before, that is exactly the activity that needs a lot of computing power. That is the computing activity for which the miners needed to invest in heavy computing material. Okay, and it's because there is a lot of work that is done here to find and to create that block signature. That is the reason why that is called proof of work. When you find that signature, and that signature is easily recognizable because there are some format conditions, so everybody can see that the signature is, can see easily that the signature is correct. And with that can also see that the miner did a lot of work to find that block signature. So the signature itself is the proof of work. It indicates that the miner did, first of all, an important investment, and also invested electricity and time to create that block. Now, why is that important? First of all, the miner will have to propose his block to the verifiers, and his block will become only part of the longest blockchain if the verifiers accept that block. So if he inserts dishonest transactions, then the verifiers will reject that block, and thus the miner will not receive his reward transaction. And so he is hurting himself economically. So the proof of work is the almost guarantee for honest creation of a block. Okay. So as said before, all these miners over the entire world, they enter into the race, and the first miner that finds the signature to his block will send that block to, again, the verifiers. You see the blue arrow here. So the unvalidated new block is sent to the verifiers. And when the nearest verifier receives that new block, that verifier or node will also forward that block to neighboring nodes who will do the same thing. And again, here the new block will ripple in fractions of seconds over the entire network of verifiers globally. And all these verifiers start again to their verification work. They will verify the entire block before accepting that. And it's very important to note here that each node does that independently from the others. Each node operates autonomously. Okay, and to validate the new block, a node, a verifier, will verify again all the transactions that are in that block for authenticity, integrity, and absence of double spending. Will verify if the reward transaction is compliant with the rules that are written in the protocol, and will also verify if the block signature is correct. And if the node considers that block is correct, then the node adds that block to the local copy of the blockchain. So each node, each verifier in the network has an entire copy of the blockchain that has been independently verified by that node. A node accepts only information, accepts only blocks that she or he or the software actually verified completely. Okay. So that is the way that a new transaction finds its way in a block, and then finally in the new longest blockchain created by proof of work. Now, important to note is that with that new block that has been added to the new longest blockchain, the reward transaction created in the block becomes reality, becomes part of the blockchain, and becomes part of the truth. Okay, and so at that moment you have kind of the issuance of new crypto, in this case talking about Bitcoin blockchain, of new blockchain, and with these Bitcoins being available on the wallet of the miner, they become part of, or potentially become part of, new transactions in the economy. Okay, and that's the way that new Bitcoins or new crypto, as a reward for the miners, make their entrance into the real economy and society. A last point to note is that with that blockchain, that new that longest blockchain, actually all the transactions that are part of that blockchain, and actually all the transactions that took place in the economy that has been treated through the blockchain system, become part of that one single shared truth, shared transactional truth. Okay, and that's an almost real-time transactional truth that is shared with the entire economy, and which potentially proposes efficiency gains, proposes opportunities for new value-creating business models, and so on and so on. Okay, so that is the operational overview for a blockchain that operates according to the longest chain proof of work consensus rule. I hope that this little presentation gave you some more insight, helped you to warm up a little bit for the rest of the Luxembourg Blockchain Week. I propose that I open the floor to some questions. Let me check the chat, and let me see. So Marco or Rumen is asking, en cas de, it's in French, I'm going to read in French and then translate. En cas de vol d'ordinateur et pas de sauvegarde quelque part, on perd tout les preuves de propriété. So Rumen is asking, essentially, if you lose, so let me go to our shared screen here. In case you lose your public key, you could, in case that public key is safeguarded on your computer, and you lose your computer, well, then you lose your public key and your private key especially, and you won't be able anymore to authorize transactions. Okay, Marco, I hope that answers your question. Rumen, sorry. And then Marco asks, aren't the miners a subcategory of verifiers? Are there rewards also for the verifiers, obviously in a smaller amount? So, good question. Good question. I should sleep a night over it to answer your question. I actually consider them independent from one another. And I think this independence is very important because if all the nodes are also miners, then there is a potential conflict of interest. So verifiers should be independent from miners because there is this verification function, which is fundamental in the functioning of the blockchain system. And the reward for verifiers is completely absent. The reward for verifiers is that they are the system, that they maintain themselves their own transaction system. Okay, they are the verifiers of the system they use themselves. Okay, so that is the intangible but foundational reward for the verifiers, that by being a verifier, you are the system. Okay. Rusank is asking, Hiram, will you be sharing this presentation? I will ask Tom and Emily how to put that, the slide at your availability. I'll definitely try to find that out. Let me check the time. Okay, we have a few more minutes. So Christoph is asking, what is the minimum investment amount to become a miner? I don't know. I don't know. It depends, first of all, on the blockchain. I have no clue. There are websites that allow you to have an idea. Currently, in the Bitcoin blockchain, the investment is huge in order to make a chance to win the race. So the computing capacity needed to make a chance to win a block is huge, and so the investment also is huge. But I don't have specific numbers. Let me check. So I invite you to ask your questions. and put them in the chat. So Christoph, okay, we just answered that question. Thank you, Christoph, for your question. I'll give it a few more minutes. So please shoot, don't hesitate if you have further questions. We can, of course, also chat offline in the networking, or you can also, of course, contact directly the Blockchain Academy through our website. So yeah, if there are no further questions, then I hope that this presentation helped you a little bit, at least helped you to warm up for the rest of the Luxembourg Blockchain Week. Leaves me only to wish you a nice continuation and productive and insightful sessions until Friday. Wishing you all a very nice day. Bye-bye.